So in this video, we're going to go through combinatorial analysis, which is when we combine lots of analysis to find a structure at the end of the question. So if you're coming to this video, you must know IR, NMR, carbon NMR, okay, and empirical formula already, because we're going to join them all together. So what is combinatorial analysis? Basically, it's an empirical formula. You'll be given percentages, and that's 1 to 2 marks in the question. So if you don't know anything, please do it. You'll give a mass spectra, or they'll be given a mass spectra, and that will give you the M+. You can use the M+ to compare to the empirical formula and find the molecular formula. Again, 2 marks without much effort. Infrared spectroscopy, quite easy. Recognise the type of bonds and just look for C double bond O's and OHs most of the time. And there are 2 different types of OH, and they're on the data sheet, so make sure you read the data sheet. Carbon NMR, just state the different types of environments, and if you can, get some information about carbons bonded to oxygen. Again, you don't need to know anything, and you might even have 3 to 4 marks at this point without knowing really anything about the compound. And then finally, use the proton NMR to find out what it is. And this is the complicated bit, this is the hard bit. Okay, if you don't know what it is, okay, have a go anyway, because they might give you marks for different functional groups and things and stuff like that, and having something that is the right formula for this up here, okay? So don't ever leave it blank, okay? Because it's 6 marks you could really do with, and it's the end of paper 2 or in paper 3. Now, let's go through one. So this video is intended so you go through it and you actually do the question, and you will do a section at a time. So this section is the empirical formula. Please stop the video, do the empirical formula. Okay, the empirical formula looks like this. Okay, and you'll get these numbers and you'll get these numbers. Okay, again, I'm not going through how to do it because you've done it in other videos and things like that, and you can see it here. You've got the numbers here. They are not a whole number. Well, one of them is not a whole number, so you need to times it all by 2. Times it by 2 gives you the whole number, and you get C2H3O2. We'll put that over here. Okay, and we've now got our mass spectra. Now, mass spectra, I've labelled this because it's hard on a video to see. So I've labelled the M+ down here as 118. Now again, stop the video. What do you do with 118 at this point? Okay, stop the video, do your calculation. So what you do is you find out what the fragment is here. What is that? And it's actually 59. Okay, and then you find how many times 59 goes into 118, and it goes in twice. Which means that you must times the formula you got, the empirical formula, by 2 to get your molecular formula. And now we have our molecular formula, we're going to move on to carbon NMR. Okay, so carbon NMR has 1, 2, 3 environments. So that's what you have to say for the exam to get yourself a mark, okay? 3 carbon environments. Now what you do notice, and hopefully notice here, and they'll have it exact in the exams, is that this line is double the height of this line and this line. Which means each line and the height of it refers to 1 carbon usually. So that means the height up to here is 1 carbon. So if I go up to here, which is double the height, that means that must be 2 carbons. 1, 2, 3, 4 carbons. 4 carbons, so it matches, and 3 carbon environments. If you want to get all the marks, sometimes just say what environments these are. So this is C bonds down the bottom there, and this is a C double bond O up here. And you can get that from the data sheet, so it's not a difficult thing. Let's go to the infrared. Now we look at the infrared. We've already got our data going forward, and there's only 2 groups we really look for. Bonds we look for, and the common mistake is to call them functional groups. They are bonds, just bonds. So therefore, this is your OH. Notice a peak, and then a peak, and then a peak. So there's 3 peaks in this. This, if you look on your data sheet, has got to be CH, because it's around 2,700 to 3,000. This is your OH, and this is your OH. So it looks like you've got 2 OHs because of that. Okay, and in the exam, they'd make it even more obvious. They'd round it out and do 2 really obvious peaks. So don't worry about the complicated version of this. And also, this bit here is C double bond O. Okay, again, look at your data sheet, and you've got those bits of information. So we'll take those bits of information and we'll park them down here. So we have all our information down here. Let's move on to this proton NMR. So proton NMR, I'm not going to Photoshop this to make sure that this is perfect like you will see in the exam, okay, because it takes a lot of time, okay, and this is a real NMR. So let's just explain to you what each peak is, so we don't have to. So 2 singlets overlapping, a quartet of relative peak area of 1 and a doublet of relative peak area of 3. So we've got these these peaks, and let's see what they are. So first of all, that's got to be a CH3. It's a CH3 and it's next to a CH because that means it's got 1 hydrogen on the adjacent carbon. So 1 hydrogen on the adjacent carbon. This must be next to the CH3 and a CH because it is next to 3 hydrogens on the adjacent carbon because it's a quartet. So that's a CH and a CH3. Now, this then says that I have got 2 singlets overlapping and it looks like a COOH. But I don't think it's a COOH in terms of 2 COHs, again, because of that terminal CH3 at the end. It's got 1 terminal of CH3 and the other terminus must be COOH. So I think I've got this. That means that other peak here must be an OH because OH can appear anywhere along the NMR. But I'm not sure, okay? I think that's it, but I'm not sure. So what I need to do is I need to compare this to the molecular formula and try and put the jigsaw puzzle together. Now, if that's the case, let's start with the obvious thing, which is the carboxylic acid. Okay, so the carboxylic acid is done. So we have done that one. Then I think I'm going to do the other end. So I'm just going to do it, and this is how I recommend you do it in the exam. Just start drawing things, okay, and start seeing how things fit together. So I've done that bit. So I have done this, and I have done this. Okay, then we go to the OH. Now, important thing here is we have to put an OH on, okay, because an OH is there, we think. Okay, and now let's compare it to the actual molecular formula. How much have we used up? So we used up 3 carbons. There's 4 carbons, so I need to add in another carbon. Okay, and I need 6 hydrogens to be used up. 1, 2, 3, 4, 5, 6. Well, that works out when I put the OH on. And then I need 4 oxygens. 1, 2, 3. There's another oxygen to be added, right? And I'm going to put that oxygen here. I'll talk about that in a minute. Okay, so I've got that. That's what I've got to put on. So I've got to decide where I put the oxygen, where I put the carbon, and it makes sense that the carbon just joins the whole thing up. Okay, so that's what I would test first of all, join the whole thing up. So I've got that all joined. Then I've got the OH. So I've got option OH here, OH here. If I put the OH here, then that maintains this nice group and gives me the quartet caused by the CH3 and gives me the doublet that is the CH3 caused by the CH. Now, if that is the case, okay, if the OH is here, that works. Now, how can I put the O on then? Well, the O must go on there, but all carbons need 4 bonds. So if that's the case, it must be a double bond O, and that must be an OH. And that, dear viewers, okay, is the first of the combinatorial analysis questions which come up at the end of paper 2 and possibly paper 3. We've got 3 more to go through with you. So again, next one, try and work it out yourself. Okay, stop the video, do the various parts, stop it before the analysis and try and work it out yourself. Okay, and I hope that was helpful.